As I mentioned in class last night when each of you left after completing the quiz, I said I would be making a short video to briefly introduce some of the topics that we'll be covering in Lesson 5.1, so that when we get back together again on Wednesday evening, we will have put a dent in this lesson and we'll hopefully be able to work through examples to complete the lesson and also work through examples in Lesson 5.2 to get us back on schedule a bit. So Lesson 5.1 is our first lesson, of course, in Chapter 5, where we're going to be revisiting some rules of exponents. But now we're going to be applying those rules to more than just positive integers. So our targets in this lesson are, we want to be able to simplify numerical expressions that have integer exponents, which may be positive, negative, or zero. We also want to be able to simplify algebraic expressions that have integer exponents. Again, they could be negative or zero now. And then we want to be able to multiply and divide algebraic expressions that have these integer exponents in them. So one of the things that we talked about early on in the semester is a basic rule, and it looks like my formatting hasn't come through real well in this slide, but a basic rule for exponents in that when you have b to the n power, all that means is you're multiplying b over and over and over and over again n times. So you have n factors of b, okay? And we've applied that to positive exponents. Now we're going to be applying that rule to exponents equal to 0 and to negative integer exponents. So first of all, we want to recognize that whenever you raise anything to the 0 power, it will always equal 1, okay? And this slide demonstrates why. If you have, and again, formatting didn't come through well here, so let me correct this. If you have x to the 4th, and it's being multiplied by x to the negative 4, our rule of exponents says that we should add the 4 and negative 4 together, and that'll be equal to x to the 0. Well, because x to the 4 times x to the negative 4 is going to equal 1 now, because anything to the 0 power is 1, the only way you can multiply two things together and have their product be 1 is if those two things are reciprocals of one another. And therefore, if x to the 4th is multiplied by its reciprocal, 1 over x to the 4th, the product would be equal to 1. Okay? So, this rule here tells us that when you have anything raised to a negative integer power, that is the same as saying take the reciprocal of that value. So b to the negative n power is really the same as 1 over b to the positive n power. These two demonstrate that. If I have x to the negative 5 power, that's the same as 1 over x to the positive 5 power. Or if I have 2 to the negative 4 power, that's the same as 1 over 2 to the positive 4 power, which would be 1/16. 2 to the 4th power is 16, so 2 to the negative 4th power would be the reciprocal of that, 1 over 16. And these examples demonstrate that as well. So we want to recognize that these properties that we've learned for exponents are going to hold now for all integers, not just those that are positive, but now for negative exponents as well as for exponents equal to 0.